Now, what if they ask a question where it is not along the nice symmetric pathway? What if, for whatever reason, they asked us about point D? What if they say and ask, what's the velocity there? They could ask, how much time did it take to get here? They could ask, what's the range here? Now, they're going to have to give you some other information because it's not along one of the two symmetric points. It's not along the halfway point or the full launch. So they're going to have to give you a little bit more information. But if once they give you that little bit more information, you should be able to utilize it using the same methodology. What's the velocity at point D? Let's say that this range was, hold on, I gotta see one thing, hold on. Let's say that this was at so let's say this flew 7 meters, and for whatever reason, we want to know the velocity right before it reaches, or right at when it reaches this 7 meter point. So maybe there's a wall here, maybe there's some problem if you're trying to clear a barrier. We don't know. Not only could we ask what's going on with 7 meters, not only can we ask what the velocity is, but we could ask at what height is it at this point, how much time in the air was it. We can ask lots of information regarding it, but I'm going to ask about the velocity because as we find velocity, we're probably going to have to find other information along the way. All right. Same process though. I mean, we have to know we're going from point A to point D. So you gotta, again, know where you're starting and where you're going. And again, since you've changed the positions, you have to change all of your information. So I could give you one projectile motion scenario and I could basically have like 3 or 4 different problems from that same information, that same initial information. All right, well, the beginning information at point A doesn't change. We know the given components of the initial velocity. In this particular case, I do happen to know, I was given information that I have traveled 7.0 meters. So I was given that. Otherwise, I don't really know much. I don't know the time in the air. I don't know the height. I don't know the velocity here at all. I do know acceleration, of course, because it's in free fall. I don't know the time. Well, I want the velocities. I know the x velocity, by the way. No matter where in flight it is, I don't even have to do any work. X velocity is here. The x velocity, v2x if you will, is still 8.0 meters a second. Because the x velocity doesn't change throughout the flight. Again, the cart was always under the ball in that video. But if I'm going to find the overall velocity, which I need the overall velocity, I need the y velocity. So I'm sitting here and I don't have enough information. I need more information. Well, if I can't get enough information from one direction, I got to go to the other. Well, it's pretty evident from the x direction I can find time. So, Vx equals delta x over t. Again, the only formula you're using from the x direction. You're not using any of those acceleration formulas with the x direction information. And if that's the case, I know 8.0 equals delta x. No, I know delta x. I know that's 7. 7.0 over t. And here I can find the time. So it's 7/8. And I had, a version of 12.5, right? So 7 divided by 8. Oopsie, hold on. 7 divided by 8. 0.875. So 0.875 seconds is in the air. So if I know that, if it's time in the x direction, it's also time in the y direction. Cool. Now that I know the time in the y direction, I can utilize that information and I can find what I'm looking for. I'm looking for Vy, because I need to know Vy so I can find the overall V. Okay, so V2y equals V1y plus acceleration time. That's the easiest formula to use. V2y equals V1y. Well, V1y was positive 6.0 minus 9.81 times the 0.875. Sorry, it's a little squished. I hope you can see that. Here, you know what? Let me rewrite it. So we had that information. So I'm gonna make this a little bigger so that it's clear for you. Wow, Tapper. V2y equals V1y plus AT. V2y equals positive 6.0 plus negative 9.81 to be explicit about that. Use of negative 8.1, 0.875. I can figure this out. V2y equals, and if I plug all that in, so I'm going to have 9.81 times 0.875 and 6 minus negative 2.58. Negative 2.58. So negative 2.6 meters a second. Which makes sense because, I mean, from the previous information, we knew that the 7 meters was well beyond the halfway point, so we should be coming down with velocities. If this distance were before the halfway point, then I better be getting velocities that are positive because it's still moving upward. And if I know that this is negative 2.6 downward, I'm not done. I can use this 2.6, I can use this 8.0, and what I should do is then move this over, head to tail, 2.6 y velocity downward, and then of course I can take the x and y components, I can do Pythagorean theorem, I can find the velocity at d, I can find also the angle. Now I'm not going to do all that right now, that's vector work which we've done before. No need for me to waste even more of your time on a YouTube video doing this. But that's finding the velocity. Now that I know the time, I can also find the height if I wanted to. I'm not going to do it, but if I use another formula, I could find delta y here and find the height at which this is happening. So all you need is a little bit of information, and with organization, you can find, and the concepts of projectile motion, constant velocity and free fall, you can find a lot of stuff. So, start practicing. That's the only way you're going to get used to these problems. And we'll start you off with the basics, and then we're going to kind of graduate you into the more sophisticated problems as we move forward. Fun times. Thanks.